Hello, grade sevens. I'm back, and hopefully my microphone works better now. You should be able to hear me. I got my microphone right by my mouth. We are starting our probability unit, and I always get asked in math. I think every math teacher gets asked, when are we ever going to use this? Well, you can use what you're about to learn anytime someone says, what are the chances? You can use this very cool stuff. First things first, the sort of equation that we're going to be using for probability and always going to have to be remembering and referring back to is the probability of something occurring is the number of favorable outcomes, the number of possible outcomes that could occur that you want, that you're looking at, divided by or over top of the number of possible outcomes or the number of total possible outcomes. So we'll look a little bit more what this looks like. So we can express the probability of something using a fraction, a decimal, or a percent. And luckily, we just learned about using all those things. So we should be able to go between the two. So if something is completely impossible, is never going to happen, we would say it has a 0% chance of happening. So that could be down here on this end of our number line. So that would be 0, which is the number written as a percent. That's 0%. And written as a fraction, that can be written as 0 out of 1. So here we have our decimal, or just number form, our percent. And here we have our fraction. So if something is definitely going to happen, then we would say, well, that's like 100% guaranteed. That thing's going to happen, whatever that may be. 100% guaranteed that Mr. Wallace will beat any grade 9 boy in a basketball game, one-on-one game. That would be 100% guaranteed. That would be at the other end of our number line. And all this number line has to go through actually is from 0 to 1. Because the number 1, written as a percent, well, we take that decimal number, just the number 1, times it by 100. That is 100% chance of happening. As a fraction, that is just 1 out of 1. It could be 50 out of 50 or 12 out of 12 or whatever. 1 out of 1 it's going to happen. Every time that's going to happen. It is a certain event. And then you could have any number of things in between here. So right in the middle, you would have 0.5, which would have a 50% chance of happening, which is going to happen how many times? Well, 1 out of every 2 times is 50%. You could also have, between those two, 0.75, which would be 75% chance happening. So it's more than likely going to happen, but there's still a reasonable chunk that it won't. Which would be 3 out of 4. So this is sort of how we can portray different probabilities on a number line. Really, we're just looking at, we can write it just as a decimal, as a percent, or as a fraction. So I'm just going to go through a bunch of different scenarios with you using a bunch of different ways that we look at probability often in this unit. And hopefully everything will make more sense. So we're going to be using dice probably quite a bit, talking about probability. Dice is often used involving probability. Any board game that uses dice, there's some chance to that game. There's probability happening. So here we have what looks sort of weird. We have this P, and then in brackets we have the 6. So this is just sort of the notation that we're going to be using. And really what this is asking, it says, what is the probability of getting a 6? So P6 is, what's the probability of getting a 6? So the probability of getting a 6 is equal to, well, remember the equation is favorable outcomes, did I spell that right, over total outcomes. Well, the favorable outcomes, we're just looking at not what are the favorable outcomes, we're looking at how many there are. So the number of favorable divided by the number of total outcomes. So how many favorable outcomes are in this case? Well, only one. The only favorable outcome would be getting a 6 if you were to roll that dice. So there's one favorable outcome. How many different possible outcomes there on a 6-sided die? Well, there's 6 different sides, 6 different numbers. So there's 6 total outcomes. So you have a 1 out of 6 chance of getting a 6. What is the probability? What would be the probability that you're going to get an even number on top when you roll the dice? Well, again, we're looking at the number of favorable. So again, how many outcomes there are that would have that, and over top of the total. So again, there's only 6 different outcomes, so it's going to be over 6. How many of them are even? 1 is not even, 2 is even, 4 is even, 6 is even. So we have 3 favorable outcomes, the even numbers. So it's 3 favorable outcomes. So that's 3 over 6, which is also equal to, you can divide both of those by 3, 1 out of 2. Or we could write that as 0.5, or we could write that as 50%. And any probability you can turn from a fraction into a decimal, into a percent, using the skills you already have acquired. Okay, so that's dice. So dice are pretty straightforward. Not all dice are 6-sided. You can have 12-sided dice. You can have 4-sided dice. But often we'll be using 6-sided dice, but that's the basic idea with dice. Another object we'll also often be using is little spinners. And you can imagine that if this arrow, if I could spin it around as if we were playing Twister or something like that, it would randomly, more or less, land on one of those sections. So what is the probability that if I spun this spinner, that it would land, the probability of landing on a 3? Well, how many 3s are on this board? Well, there's only one 3, so there's only one favorable outcome. And how many total different sections could it land in? Well, there's 4 total sections, so it's 1 out of 4, which is also equal to 0.25, which, if we times it by 100, would be 25%. Those numbers are all just the same way of writing the same number. Okay, what's the probability that it is not 2? Well, now we have to think, what are our favorable outcomes? So we don't want it to be 2. That would be our favorable outcomes. So the probability that it's not going to be 2 would be, well, what's the probability of it being 1 or 3 or 4? So we therefore have 3, 1, 3, or 4 is 3 favorable outcomes out of, again, the 4 total outcomes, which is equal to 0.75, which is equal to 75%. What is the probability that it is going to land on a color? So I spin this spinner. What is the probability that it's going to land on a section that is colored? Well, one section's purple, one section's blue, one section's red, one section is green, which means that they are all a color, which means that all of them are favorable outcomes no matter where it lands. So that would be 4 out of how many total? 4, or 100% chance that that is going to occur, that I spin that and it will land on a color. Okay, so you can have certain outcomes as well as impossible outcomes. Spinners can obviously have more than 4 sections. Each section could be the same. You'll have to be looking at spinners like this, where, you know, maybe instead of this being a 3, this was also a 2. And then you'd have a probability of getting a 2 versus a probability of getting a green, and so on. Options are endless. Another common scenario in this unit will be looking at a bag of marbles or a bag with some type of objects in them. In this case, we have this bag of marbles, and it's see-through, so we can actually see what's in there. Or at least we pretend we have X-ray vision right now, so we can see what items are in there. But when you're reaching in, you don't know. So if you were to reach into this bag and pull out a marble, we're imagining that we can't see what marbles are in there, so it's a total random chance what marble you are going to pull out of that bag. So if you were going to reach into a bag, eyes closed or whatever, and reach into this bag, specifically with these marbles, and pull out a green marble, well, what would the probability, what are the chances that you'd get a green pulling a green marble out of this bag? Well, the favorable outcomes, remembering we're always looking at number of favorable outcomes, number of fav over the number of total outcomes, Well, the favorable outcomes would be green. So how many favorable outcomes are in this case? 1, 2, 3, 4. So there are 4 favorable outcomes out of the total number of outcomes. So those 4 are possible outcomes, but there's also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 marbles in there in total. So that's 4 out of 10, which is equal to 0.4, which we could also write, if you times it by 100, as 40%. Okay? Now we could also be asked, what is the probability of drawing a primary color out of this bag? Well, a primary color is a color that needs to be used to make other colors. You can't make it using other colors. So our primary colors, remember in our color wheels from elementary, is blue, red, and yellow. Blue and yellow makes green, blue and red makes purple, yellow and red makes orange. So blue, red, and yellow are primary colors. So how many of these marbles are primary colors? Well, there's 1, 2, 3, 4, 5, 6. 6 of them are primary, so that would be our favorable outcomes if we were to pull a primary one. Again, we're looking at the probability of pulling a primary color. Now it's not out of 4. We don't just count how many are left. We count out of the total. So again, there's still, or imagine we put the green marble from last time back in, there's still 10 outcomes, which it would then be 6 out of 10. We could write as 60%. Okay. Lastly, what is the probability of reaching into this bag and pulling out a square object? Well, in this bag, there are no square objects, so favorable outcomes would be 0. You could not get that favorable outcome. Imagining that pulling a square would be your favorable outcome. And there's still 10 possible outcomes, what you could get. So 0 divided by 10 is equal to 0, which is equal to 0%. That is an impossible outcome. Okay. So those are a few situations. Last situation that you will often run into is using a deck of cards. So there's a few sort of stats you need to know about a deck of cards. First of all, how many cards are there in a deck of cards? There's 52. So there's 13 in each suit. So there's 13, this we call clubs. These ones are spades. Clubs and spades are black. This is hearts. And this is diamonds. So there's 13 of each. You can imagine ace is 1, so we go 1 through 10, and then jack, queen, king. So there's 13 in each suit. There's 4 suits, so 13 times by 4 is equal to 52. So in a deck of cards, there's a total of 52 different cards that you could pull from one deck. So really, that's the number that we're often going to be using for what our total outcomes are. So let's first look, okay, well, what's the probability of getting a king? Well, a probability of getting a king, well, you could get a king of clubs, you could get a king of spades, you could get a king of hearts, you could get a king of diamonds. It doesn't say what type of king, it just says get any king, which means that if you had a full deck of cards, the probability of getting a king, well, there'd be 4 favorable outcomes out of the total number of cards out of 52. We needed to simplify that. Really, out of every 13, out of every suit, there's only 1 king. So if we were to simplify this, we could divide each of those by 4. This is 1 out of 13. There's a 1 out of 13 chance. I could figure out on my calculator what the decimal percentage, but I'm not going to. So here's where it sort of becomes, you have to just read carefully. I could be asked, what is the probability of getting an ace or a spade? So I could get an ace or a spade. Either one of those, it's saying, this or that, would be favorable for me. So I could get an ace. Well, there's 4 aces that I could potentially choose. So I'm just going to erase that. So I could choose 1. Okay, there's 1, 2, 3, 4. But I could also get just any spade, and that would be a favorable outcome. That would be what I want. So I have more than just 4 favorable outcomes. I don't want to count the ace again. I can't count the ace twice because there's only one ace and I can only pull it once. So I have 1, 2, 3, 4 already. Then 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 total different cards that would fulfill what I want here, fulfill my favorable outcome. Ace or a spade. Either one of those, whether it's an ace or a spade, I'd be happy. So there's 16 I said, there's the 13 spades, as well as the 3 other aces. So it's 16 out of 52. Okay? I could, of course, simplify this. So I could say, well, I can divide 16 by 2. These are both even numbers. Divide this by 2. Okay, so this is actually 8 out of 26. Well, I can divide each of these 2 by again. If I would so like, divide by 2, divide by 2. So that's 4 out of 13. I can divide these. Oh, no, I can't divide 13 by 2. So 4 to 13 is my fraction in simplest form. I could have also turned my initial fraction into a decimal and then a percentage. Okay, so that's if I got an ace or spade. So what if it asked me if I wanted an 8 and a heart? So I wanted the card that I choose for it to be favorable, for it to be what I want. What is the probability of getting an 8 and getting a heart on one pull? Well, the only possible card that fits both of those, well, it has to be an 8. Well, we have 4 different 8s, but the only 8 that is also a heart is just this card right here. So there's only one card that is both an 8 and a heart. So notice the difference between or and. So ace or spade left us with a large selection of what cards we could choose. But 8 and heart meant that what we chose had to be both of those things, not one or the other. And there's only one card here. This would be 1 out of the 52 cards that would fall into that category. So we only have one favorable outcome out of the 52 total possible cards that we could pick. Okay, so that is the end. Let me double check. Yeah, that's the end of the lesson. So I just went through those. We're looking at figuring out probability. Again, we're using this notation. So in your assignments, you can be writing out, if it asks you, it may ask you in a sentence, what is the probability of picking a king? Then you can write in your book, P bracket king bracket is equal to, and then write what your probability is. So that's one thing you have to remember, is that notation for how we write it down. For different suits. We will be dealing with cards a fair bit. And then just remembering all the time,